Suppose you have $5,000 to invest. Which of the two rates would yield a larger amount in 8 years? So compounded 12%, compounded monthly, or 0.1191 compounded continuously. The formulas are given on the previous problem. See the formulas above. So I'm not expecting you to memorize these formulas. Okay, so this one is A equals P1 plus R over N raised to NT, and this one is A equals PE to RT. All we have to do is just show what we are plugging it in and use the calculator. So 5,000, 1 plus 0.12 divided by 12, and how many years? 8 years. Okay, and this is 8 times 12, and the other one is 5,000 e to 0.1191 times 8. Calculator. Okay, 5,000, left parenthesis, 1 plus 0.12 divided by 12, close, caret, 8 times 12. If you multiply 8 times 12, 96, then you don't have to use parentheses potentially. But you know me already. So then 5,000 and in E raised to 0.1191. I want to put this in parentheses. And multiplied by, some calculators may not require, again, parentheses, but I don't care. Okay, so the first one, 12996. We always money, when it comes to money, we go to cents. 12964.7, it's 798, so it's 80. So based on this is the better choice. 12996 versus 12964. So we will choose this. Compounded 12 times a year, it's a better, and with 12% is a better option. Any questions on this problem?
No questions on that problem. I do have a question about number.
We have number 5 next. Hold on 1 second, hold your thought. Don't forget what you want to say. So we have number 5. Any questions on 3 before we move on to 5?
No.
Okay. Let's move on to 5 then. For some reason I lost the test. I'm going back in. Okay, number 5. 1, 2, 3, 4, and then 5. Okay, use the properties of logs. So we have log base 4 of, I think it's the cube root, is it? I can't see, my devices are so far away from me. Is this correct?
Yeah.
Okay, perfect. So remember, I have to put in front 1/3, first of all, exactly what we just discussed. Of 8, a to the 6th, b to the 3rd, c, b minus 1. So now, 1/3, log of this, log of this, log of this, log of this, log of this. 1, 2, 3 will have positive in front, 1, 2 will have negative. So log base 4 of 8 plus log base 4 of a to the 6th plus log base 4 of b to the 3rd minus log base 4 of c minus log base 4 of b minus 1. See, I'm not multiplying or distributing c in here to get only one log. So please don't do that. Next, I know that I cannot simplify this, so I will have to distribute 1/3 log base 4 of 8. Here I can put 6 in front divided by 3, so plus 2 log base 4 of A. 3, but with 3 will disappear. Log base 4 of B minus 1/3 log base 4 of C minus 1/3 log base 4 of B minus 1. And this is the final answer. Is this okay? Can we move on to Sam's questions now? Any questions on this? Everyone?
No.
Okay. Sam?
Just a real quick question for number 1. What would be
Oh, you said number 1?
be for that?
You're talking about number 1?
Yeah.
Let me go and see
Yes.
number 1. Go back up. So we have f of x, which is 2 raised to x minus 3 minus 4. So the base function will be 2 to the x. Then you have to address x minus 3. That's the first step. So this is right 3. And then down 4. So when you graph, I will graph 2 to the x, which I know always remember, pandemic, right? Increasing function on all its domain, scary function in this day and age. So 0, 1. So this is 2 to the x. Then we shifted 3 units to the right. So this point gets transferred right here. So here's the new function. 2 to x minus 3. Now I have to shift this graph down. And I have to shift the horizontal asymptote first. The horizontal asymptote is at 0. But I have to shift it 4. Y equals negative 4. So now this point moves here. Two to x minus 3 minus 4. This is the final graph. You don't have to shade it like that. I just want to make sure you see. Now, I'm probably asked to determine algebraically. Yes. So I need to determine this, which is the y-intercept, and I need to determine this, which is the x-intercept. For the x-intercept, I have to set y equal to 0. Y equals 0 for the x-intercept. 2 to x minus 3 minus 4 equals 0. I know that this is an exponential equation and it's not a difficult one. I move 4, and also I can change 4 into 2 squared. And now I know this is an easy situation. X minus 3 equals 2, so x equals 5. So this point must be 5, 0. For the other one, for the y-intercept, it's easier because I only need to find f of 0. So for the y-intercept, I find f of 0. So 0 minus 3 is negative 3. 2 to negative 3 is 1 over 2 to the third and minus 4. And this is 1 over 8 minus 4. 32. 1 minus 32, negative 31 over 8. So this point is 0, negative 31 over 8. Find the domain and range. Okay, very good. We don't have any problems. It's an exponential function. But the ranges you see, can anyone identify the range for this problem?
Wouldn't it just be parentheses -4 to +1?
That's it. Did I answer your question or?
Yes, you did. I remembered how to do all the transformations. I just couldn't figure out. I couldn't remember what the function base was for that.
Okay, yes. The exponential 2 to the x.
Thanks.
Thank you. Anything else you would like to work on?
I had a question. I'm having trouble with the logistic growth functions.
Yes, can you give me an example?
I don't really numbers that go with it, but
I couldn't hear you very well. Is it you said log functions?
yeah, but it was the ones that are like you have to like they're the word problems kind of like you need to like gives you like here's one.
Yeah, can you find one from the test? Is there one in the test, the old test?
Let me see.
Or any problem actually.
Oh yeah, it was number 9.
Okay, so let's take a look at number 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Very good. So we have a function. This is the logistic growth model, which is 30,000 divided by 1 plus 20. I think it's e raised to negative 1.5t. Correct me if I'm wrong. Did I see that correctly? Describes the number of people, f of t, who became ill with the flu t weeks after its initial outbreak in a particular community. Okay, so this is the number, people, and t is in weeks. Okay, how many people became ill when it began, when the epidemic began? How many people were ill by the end of the 4th week? So, and then what is the limiting size of the population? So how do we determine the number of people who became ill at the very beginning? Initially, originally, beginning. What do we do to determine that? Exactly. So we have to find f of 0. We'll find it in a moment. Part B. How many people were ill by the end of the 4th week? F of 4. And the limiting size is when t goes to infinity. And we'll see in a moment what happens. Okay, so let's put the function in the graphing calculator. Clear if you have anything else. 30,000 divided by, in parentheses, don't forget the denominator has to be in parentheses, 1 plus 20, e, in parentheses, negative 1.5x, close the parenthesis for that power and close the parenthesis for the denominator. Let me know when you have this in your calculator. And we'll continue from there. We have it?
Got it.
Okay, everyone? Then we go to second and table, and we plug in 0, we plug in 4, and for the limiting size of the population, put in 60 weeks, 100 weeks, 200 weeks, and tell me the answers, please. What do I write at 0? At 0, I found 1, 4, 2, 9 if you want, people. If I have 0.6 of a person, I don't have a person, but okay, algebraically we can write that. 28583. And what is the limiting size of the population? When t goes on forever.
30,000.
Exactly. And that is the y-intercept. Y equals 30,000. Another y-intercept. I'm sorry, horizontal asymptote, I meant to say. Horizontal asymptote. So the limiting size, 30,000. Assuming that nobody comes in from the outside of the community, eventually everyone will get the flu. If the model is correct.